Hey, welcome back Chuds to another Senior Science video. Today we're going to do a basic rundown of elements, isotopes, and compounds for my semester chem final. So we're going to start with elements. Elements are the building blocks of our universe. Everything and everyone contains them. And this table right here is our cheat sheet to understanding them. But looking for a single element, when you don't know how it's organized, can be tedious. And that's why we separate them into blocks. Let's start with the P block. You're probably most familiar with this one because it contains carbon and oxygen, but it also carries some metals and nonmetals, and metalloids. Then we have the D block in the middle, containing mostly metals, including gold and copper, and transition metals. Then there's the S block, with alkali metals and alkaline metals. Oh, and helium. Then finally, we get to the fun stuff, the F block, which contains most of the radioactive elements on the periodic table, with silvery and whitish metals, conductive or magnetic elements, and glowy elements. They glow and stuff. Those are all the blocks of the periodic table. Now, I probably spoke of a few terms you don't know, so I'll tell you now. Transition metals. Metals like copper that can change and form bleh. Transition metals. It's like copper goes from that thing it just works. Alkali metals, they're highly reactive metals. Alkaline metals, they're like alkali, but I don't know, stupid. Now that we have that explained, let's go to my crack house, my favorite crack cave. My crack house cave. Crack. Welcome to my crack house, crack cave lab. Now, what even is an isotope? Well, it's not too complicated. It's basically the number of protons, electrons, and neutrons inside an element that make up an isotope. Here, I'll show you. To demonstrate, I'll be creating boron. Go like... Yeah, and then... Give me like... No? Oh, but you can decrease it by one. That, you'd be like, boom. Be like, boom. Have it be like... How do we even count the isotope count? Count the isotope count. Since we made boron, how do we even count it? Since we made boron, how do we even count how many isotopes are there? Here, I'll show you. The 11 represents the mass number, protons plus neutrons. The 5 represents atomic number, protons. You can have the mass number just be 1 or 2 off and it can still remain the same element, with very minor differences. You can take example from carbon-12 and carbon-14. They have different numbers, but they're practically the same thing. That's what isotopes generally are, just different forms of elements, though with very small differences. So small that they mostly just go under isotopes. They're like apples. Even though they're all called apples, a lot of them are different in many ways. And that's what isotopes are. Let's move on to ions. 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 Alright, now that we're moving to ions, what exactly are ions? An ion is an atom or molecule with a net electrical charge, formed by gaining negative charge anion or losing positive charge cation. Electrons. When you lose or gain electrons, you can either get a cation or an anion. Or when they balance out, it neutralizes. You can get a neutral ion. Ions are actually very crucial for everyone. They control bodily functions like nerve signals and nutrient transports, with common examples including sodium, potassium, and chloride. These charged particles, they conduct electricity, form ionic bonds, and even act as essential electrolytes. And that's about it. That's elements, isotopes, and ions. There was a ton of stuff, like, I was going to show you how to calculate ions, but then I was like, that's too much work, so I just won't. You're gonna have to figure that out on your own, bud. I left a bunch of other stuff out too, so you probably should just watch more competent people. Or just be better. What's wrong with you?